Okay, so just when you thought there was a good project, here's an even better one. I mean, this is just incredible. So let's talk to the guys. So can you just mention who you are?
Hi, my name's Jono.
I'm Nick.
Jake.
Daniel.
Okay, so you're Mechatronics final year BE students, and you've designed absolutely everything here and rapid prototyped it, and you've designed everything from scratch apart from the LCD panel, of course, and the servo motors themselves. So tell us a little bit about it.
Yeah, so the design, I just did the mechanical design of everything. So we've got 25 3D printed parts printed in SLS, and then we've got carbon fibre sections. These house the servos and the bearings that are used to hold the load of the arm. And then the arm sits in a steel base that we've made up as well. So yeah, 5 degrees of freedom. So we've got the base rotation going all the way down to the gripper is our 6th servo. So it's not a degree
So
of
this
freedom.
entire arm was made here from rapid prototype and the AUT 3D printing lab.
Yeah, so
designed
internally you've got your servo, normally a bearing in each joint, and yeah.
So these are off-the-shelf servos.
Yeah, so these off-the-shelf servos in the bigger joints to hide the wiring that is all hidden. We've got this shaft of the servo drives on one side, and then all the wires fed in through the other side, and both sides are protected by a bearing, and then that means that there's no exposed wiring.
So what is it? It's supposed to. So you built all this, of course, as well. You designed this, and even this housing here.
Yeah.
And of course, this is some sort of push-a-button display, and it's supposed to take these cubes, I think, and arrange them. Is that correct? In
Yes.
some ways. Can you just show me how it works? It working?
Are you talking the visual recognition?
Yeah.
Oh, so I'll get you to
Yeah,
kind
I'll
of put them in.
You want to blocks over.
So yeah, behind the kinematics, like in order to find the position of the cubes, we use a camera mounted on the arm. It's only a monocular camera, so it hasn't got any depth.
So that's it. That's a picture here. So it's showing up.
So
So
we do some video processing. We can
is this
filter
done
the
by,
image.
what's it done by though? What's the mic? What's the? Is it a
It's-
Raspberry Pi?
So it's all the processing is done on Raspberry Pi, and
Okay.
it's used with OpenCV.
Okay.
Yeah.
Oh,
So,
for the image processing, yes.
that's right, yeah. So because the blocks are a known size and we know the focal length of the camera, we're able to calculate depth of the cube and the angle that it's rotated at, doing some vector mathematics. And then so we can take contours of the cubes, and within that region, so we detect the cube face, and within that region we perform character recognition. We built our own machine learning algorithm to recognize characters, and it performs character recognition within that region of interest on the cube face. So
Well, let's see. Oh, I see.
see
That's
that it's a U
yeah.
there.
So the original idea was to have the whole alphabet, was it? And it looks for the
Exactly.
But at the moment you've just got the 3, but it's going to pick it
Yeah.
up. Okay, but that's all right.
And we could enter a phrase, and it would first store and locate each block. You
Yeah.
could enter characters, and it would then go to those characters and pick them up and place them in your desired location.
So it's going to put the T there.
Yeah.
Now it's going to do the A, is it? Oh, oops.
Yeah, well, you'll now be able to see it looking at both the.
So it's
I see
recognized
that.
T and U.
It's identified, yeah.
So yeah, obviously it doesn't matter how many letters are in the frame. I'm not sure of the full capability. That's next, but it can identify A, U, and T in there.
Very nice. So this is self-contained, or do you need a PC as well, or?
No, so it's only running off the PC because I'm just on debugging mode, so
Oh,
I
I see.
can control each of the movements. Otherwise, it would just be going through automatically, but for the purpose of being able to point it in, put your hand in the
Okay.
arena without knocking into it, for example. I've just been running it on debug so I can cycle through. But otherwise, it just goes through every move and every second at the moment. And yeah, it's going to run through and place the blocks back where they were.
Thank you, guys. That's a lovely piece of work. Cheers. Bye-bye.